All right, anybody find one? Excuse me, anybody find one as you were working through? All right, I'll just pick a couple I haven't already done, so I'll have some new ones. Let's look at number 25. On page 433, this is section 4.8. We'll just do number 25 and see what happens there. Remember, Mrs. Ford is not going to draw the pictures for you. So the book guy is nice. He draws some of these things. But let's see if we could maybe not use the picture and draw it ourselves. So a shoreline runs north and south, and a boat is due east of the shoreline. Okay, so here's the shoreline running north and south. Everybody in agreement with that? And a boat is due east, so due east of the shoreline. All right, the bearings of the boat from 2 points on the shore are 110 and 100. Assume the 2 points are 550 feet apart. Okay, so we got 2 points on the shore. Call them P and Q. And the bearing of the boat. Okay, so I'm going to put a compass point right here. And the angles, okay, the angle, there's some guy looking here at the boat, and his angle, the angle there is 110. And then at this point, there's another guy looking at the boat, and his bearing or his directional angle is 100. Remember, when they give you navigational directions, headings, bearings, whatever, when they give you navigational stuff, you have to set up a compass point and measure from due north. So that would be 110 and that would be 100. Remember, that would be 90, so we're going a little bit past that both times. Now, what do I want to know? Oh, wait, it told me something else. It said these points are 550 apart. And I want to know how far is the boat from the shore. All right, so this is a little harder one than the one we did down there on that review sheet, but I think we got this one under control. What's your thought here? Can we fill in anything? This angle right here would be 80. Would you agree? Which means this little guy right here must be 10 because in the triangle they have to add up to 180. Okay. How about, all right, let's just stop there for a minute. Would it be true that the tangent of 10 is y over x? Would that be a true statement for this lower triangle right here? Okay, now can we do something similar? Okay, this isn't solvable, but maybe we can set up another equation from the big triangle. Could we do something similar with the big triangle? Well, I don't know. What would this angle be here? I'm looking at the big triangle now. This angle would be 70. Look at the big triangle, which means this angle would be 20. So if I look at the big triangle, can I set up an equation like this? What would that be? The tangent of 20 equals 550 plus y over x. This is 550 plus y. You okay with that? Yeah, does that look familiar? Did we do something like this yesterday? Yeah, what have we got here? A system of equations, and now we have to somehow solve this system, right? So, what did we do yesterday? Will that work again, or do you have a different thought? What do you want to do? you remember? Look at your notes. So we got rid of the fractions first. So let's just multiply both sides by x, and that will get rid of the fractions. Then our equations won't look so bad. So we have x tan 10 equal to y, and x, maybe down a little bit, x tan 20 equal to 550 plus y. Is that okay? Now, remember, when we have a system of equations, we can either substitute or eliminate, right? Now, we already know what y equals, so could I take this and plug it in right here? Would that work? So then I'd have an equation that said x tan 20 equals 550 plus x tan 10. That looking okay? All right, now think about what we did yesterday. Your job is to figure out what x is. So what are we going to have to do to get x by itself? You got to put the x's on the same side. So see, some of you might say divide by tan 20, and then you'd have x by itself. You would, but you'd also have an x over there, and that's not allowed. So we got to get both the x's on the same side. And once we got them on the same side, what will we do with them? Factor them out. So instead of having two x's, now we'll just have one. And then we want to get x by itself, right? So what will I do? Divide by the big parentheses. So x is going to equal 550 divided by the parentheses, tan 20 minus tan 10. And go ahead and leave those parentheses in place, because that will remind you to type them in on your calculator. So 550 divided by parentheses. You need those parentheses. Also, don't forget, when you type tan, these come in, you got to close those off, okay? Make sure you close off those angle parentheses that just come in automatically. Did you get 2,931?
Yes.
Now, yesterday, we got done with that. We did all that work, and we got our answer, and then it really wasn't the answer that we were looking for. But this time we're good, because the question was, how far is the ship from the shore? And that's what x is. If we needed y, we'd have to plug it back in, but we don't in this case. All right, I'm going to have to erase that to do the next problem. Is everybody okay? Everything here good? Everybody good on that? Setting up two equations. All right, let's try, have we done 16 yet?
No, just do 550. I'll do 500.
All right, let's do 16. Looks kind of confusing. We have a 100-foot building. So again, I'm trying not to look at the picture that they drew for me. I'm going to draw my own. I have a 100-foot building, so here's my 100-foot building. From the top, a man observes a car. So a guy is standing in the top of the building, and he looks down here at the street, and he sees a car. Okay? Now, the angle of depression is 15 degrees. Now be very careful. Angles of elevation and depression are measured from the horizontal. So this guy's at the top of the building, he's looking straight out, and then he looks down at the car. So there's the 15-degree angle. But remember, if the guy in the car is looking up at the man, his angle of elevation is also 15 degrees. So if you want to mark that angle down there, it's perfectly okay. The angle of elevation and the angle of depression will always match because you've got alternate interior angles. But the car is moving toward the building, so the car is going this way. The next time the guy looks at the car, now his angle of depression is something bigger, 33 degrees. So this angle is 33 degrees, which means this one's 33 degrees, right? You with me, Peyton?
Yeah.
Okay. Did somebody say no?
No, I said
Okay. All right, so here's our setup. Now, what do we want to know? How far does the car travel? So we want to know this. All right, so what's your thought? Tell me you have a thought. What?
Can we make the other portion?
Call this Y? We can do anything we want. Yep. Let's call it Y. So what do you want to do that for, Taylor? We can do basically what we just did right here. So we'll set up an equation for the bottom, the smaller triangle here. We'll set up an equation for it that says tangent 33 equals 100 over Y. Agreed? Wait a minute. Is that solvable? I can solve that. Y tan 33 equals 100, so Y equals 100 over tan 33. This isn't like the last one. I can actually get an answer to that, can I? Now, that is not the answer to the question, so I can go ahead and type it in, but I'm just going to save that. All right, now what's the second step going to be then? What am I going to do now? Antonia?
Can you substitute the answer to that into Y and then do, use like the angle 15 and the 100 and then the 153 plus X?
You absolutely can. Now, let me just throw this out for a minute. How about if we call this Z? Now you're thinking, oh my gosh, Miss, why throw in another variable? Well, then we could solve the equation tan 15 equals 100 over Z. And then our answer would just be Z minus Y. So if you want to do that, you can. If you want to go ahead and instead of having the Z here, have the expression X plus, what did you say this was? 153.98. Sometimes that kind of stuff looks more complicated than it is. So personally, I would just go ahead and call that Z, find the length of that side, and then subtract the two. So you do it however you want. Let's see if we can get an answer. That's right. So we've already done that one. Now I'm going to do this one. I got 219.22. What about you? Is that what you got? Or did I do it wrong?
Yeah.
I solved the equation tan 15 equals 100 over Z. So I just did 100 over tan 15, that answer, minus 100 over tan 33. And that's how I got the 219. Okay? That one was easier than it looked, for sure. Have we done number 10? Because that one's a little bit different because it asks for an angle. Okay, so number 10 says we have a ramp leading to a freeway overpass. So here's the highway, the freeway. Here's the ramp leading to the overpass. So here's the overpass, here's the ramp going up. A ramp leading to a freeway overpass is 470 feet long. All right, where do I put the 470? Don't make it harder than it is. Where's the ramp? Isn't this the ramp? It's 470 feet long. Pretend you're driving your car, you go up the ramp. That's 470 feet long. And rises 32 feet. Find the average angle of inclination of the ramp. Angle of inclination. Where's that? Where am I gonna put that?
The angle of inclination would be that point right there.
You are exactly right, DeAndre. That's X. I'm looking for that angle.
So you use the hypotenuse and the opposite, which would be sine.
Yep. So I'll say sine X. He was thinking out loud, and that's exactly the right thought process that he having. He said, look, I got the, for this angle, I got opposite and a hypotenuse, that would be sine. So sine X is 32 over 470. A minute ago, I did a problem where I had to find an angle, but the sides were not 32 and 470. They were like 1 and root 3 and 2. What do I do now? How do I find that angle? I don't have that one memorized. What do I need to do? Go to my calculator. What am I going to press? I want an angle. How do I find an angle? What notation finds an angle? The angle whose sine is 32 over 470. That's what I'm looking for. So second sine, 32 divided by 470, and it's about 3.9 degrees. Patty, what are you doing back there? You guys are too young to remember, but maybe on old time TV. You ever see that show called Incredible Hulk? No. It was a weird show, but a guy, I even forget all the ifs, ands, or buts, but a guy, he was some kind of scientist, and I don't know, he took some chemical or something. Anyhow, every time he got mad, he turned into this big green monster called the Incredible Hulk. So, Patty.
They still have the Incredible Hulk.
Patty, don't make me mad. All right, let's see, we got time for one more. Let's do one more. It's gonna have to be a short one.
We have a long class.
How about,
You said we have time for one more.
how about number 4?
This is
Baseball
4.
problem.
We have a long class.
Oh, we do! This is the best news ever. Okay, do it. All right, we're gonna use. Yeah, no, actually, you know, I observe my teachers, and it was early in the school year. I did observe a class where the teacher did let him go, and the little boogers did not say anything. They all just got up and left, and there was still like 25 minutes left or something. I don't know. It's crazy. All right, anyway, we're going to do number 4, and then we'll do a little more review work, okay? So here we go, number 4. This is our baseball problem. The top row of the red seats behind home plate, it is 90 feet above the level of the playing field. All right, so again, there's no picture, so I'm on my own. So I am going to draw home plate, and the top row of red seats is 90 feet above. So here we are, it's 90 feet above home plate. the angle of depression to the base of the left field wall. So out here somewhere is the left field wall. And the angle of depression to the base of the wall is 14 degrees. Okay, so where does the 14 degrees go?
Bottom right.
If you put it here, you will be wrong. Angles of elevation and depression are measured from the horizontal. So the 14 either goes there or here. I prefer to put it down there so it's in the triangle. But once you know that's 14, you could find this angle easily, so that would work too. How far is the base of the left field wall from a point on level ground directly below the top row? Where does the X go? On the hypotenuse or on this side, the bottom side? On the bottom side. It doesn't say how far is the left field fence from the top row of the red seats. It says how far is it from a point on the ground directly under the red seats. Alright, so what's our function? Tangent?
Tan 14.
Tan
equals
14
equals 90 over X.
equals 90 over X. So X tan 14 equals 90 if we put a fraction. And X is going to equal 90 divided by the tangent of 14. My book says 361 feet.
Yeah.
Everybody okay? All right, we need to do a little more review, and then I will let you work on homework if we have time to do that. All right, so let's get our review sheet back out, and let's do quick review number 2. We did number 1 earlier, but now we're going to do quick review number 2. Okay, so this means I don't see you tomorrow, right? Alright, so yeah, we're gonna get this Oh, I see you tomorrow?
No, stay fine.
Oh, you guys don't know better than I am.
When can we stand on
Thursday at the latest. At the latest, yep.
Wait, tomorrow's my start?
Alright, so here are the first 4 anyway. Let's see if we can crank through these. I know we can get the first 2 done in a snap of a finger. Cotangent 2 pi over 3. Cotangent 2 pi over 3. What's the first thing we need to do? Change it. So we know pi is 180 divided by 3 is 60 times 2 is 120. So we are finding the cotangent of 120. There will be kids who put that down as the answer. No, all you have done is rewritten the problem, right? So here we go. We're going to draw a picture of 120 degrees. How big would our reference angle be then? 60, which means root 3, 1, and 2. Then I stop. Anything negative, the 1. And then I remember what cotangent is. What's cotangent? Adjacent over opposite. So that's negative 1 over root 3 or negative root 3 over 3. We gonna get that right?
Yes.
Yes.
All right, number 2, what's this one say? What am I looking for? The angle whose sine is root 3 over 2. So I need to draw a picture of it, and that notation is like a red flag to me. I got rules. Where am I going to draw this picture? Quadrant 1. My choices are 1 and 4, but since it's a positive number, I'll draw it in 1. The sine is √3/2, which makes this side 1. Can you tell me about this angle right here? That's what you're looking for. You're looking for the angle. How big would that angle be?
60.
That's a 60. And the answer actually is 60, right? Because it's in quadrant 1. Number 3 says I'm going to need a calculator to do this. And I'm looking all the way around the circle. I do not have this notation. Do not lock yourself into these rules. This, I'm looking all the way around the circle. And what am I looking for? I'm looking for places where the tangent, solve that equation, add 1 divided by 3, where the tangent is 1/3. So think about the entire circle, everything. Where would you be looking if the tangent is a positive 1/3? Quadrant 1 for sure. Anything that's positive is going to be found in quadrant 1, but there's another place where the tangent is positive. Where?
4.
Not 4. 3. The tangent is positive in 3. Somebody tell me why the tangent's positive in quadrant 3. Because opposite and adjacent, y and x are both negative. So when you build the fraction, they become positive. Quadrant 4, x is positive, y is negative. So the tangent would be negative, not positive in quadrant 4. Okay, now the reason a calculator is necessary is because if you label this, that's what it looks like. Do we have that angle memorized? No. So we're going to go to our calculator, and what am I going to type on my calculator to find this angle right here? How do I get an angle on my calculator? Second tangent, 1 divided by 3. This angle is 18.43 degrees. There's only one way to find an angle on your calculator. Second sign, so cosine, second something. If you want an angle, that's the button that you're using. Now, if that angle is 18.43, so is this one. So the two answers to the problem are the two angles that you drew. That one and this one. So what would you put down as x? What does x equal? X equals what? 18.43 for sure. And 198.43. There's no rule for that. Use your common sense. How do you get over here? How far do you have to go to get over here? You have to go 180 and another 18 to get that second angle. Now, number 4, I must have been in a bad mood because it's tricky. It's different. Normally, when I see this picture, I'm thinking arc length equals radius and radians, radius times radians. But what's different here? What's going on? What's different? I want the area. So in other words, it's like this is a pie. I'm going to cut out this piece, and I want to know how much that is. How big a piece is that? Wow. Any thought on how to do that? You did it in geometry.
That's
a
a long time ago.
Yeah.
Hated geometry.
Me too. All right, let's do this. Let's do this. What if what if I said, find the area of the whole thing? Could you do that? How do you find the area of that whole circle? Pi r squared. So the whole thing would be pi r squared. So for this, it would be 36 pi. Would you agree?
Yes.
All right. Now, what if I cut this pi in half and said, find the area of that? It'd be half of the whole thing, right? Now, this isn't half, but this is a fraction of the whole thing. Would you agree with that? What fraction of the whole thing is it, Antonia?
105 over 360.
It is 105 3/60ths of the whole. Would you agree with that? So what is the area of the whole thing? In this circle, what's the area of the whole thing? Your radius is 2, so the area of the whole thing is 4 pi. So we have 105 3/60ths of 4 pi. Would you agree with that? And in mathematics, of means multiply. So we're going to take 105 3/60ths and multiply that by 4 pi. So 105 3/60ths times 4 pi over 1. All right, so we're going to reduce however we want to reduce. That'll go into their 90. So I have 105 pi over 90. That's 21 pi over 5 goes into there, what, 18 times? Okay, now I have no idea if I did that right. I got 7 pi over 6. You start reducing and see what you get. Is that right?
Yeah.
So if this were inches, if the radius were inches, this would be square inches because that's an area. All right, let's just do another one like that real quick, then we'll do that last problem. Do another one real quick just to kind of solidify that. Let's suppose we had a sector and the angle is 160 degrees and the radius is 5, and I want to know the area of that sector. The area of that sector. So I don't want the whole area. I want only that fractional piece. How big is that fraction? What's the fraction that I have colored in? 160 over 360. So it's that fraction of the whole, which would be 25 pi. So we have, those are going to cancel. So we have 1636 times 25 pi, which is 4/9. I got 100 pi over 9. What about you? Is that okay? All right, so that was a little sneaky. I mean to throw that one in, but it didn't turn out so bad. All right, find the height of a tree if the angle of depression to find the height of the tree. Here's the tree. Find the height and the angle of depression of a bird in the top of the tree looking at a worm. So the bird's up here, so looking down at the worm, and the angle of depression is 52 degrees. All right, so where do I put the 52? Either here or here. and the bird in the top of the tree is looking at a worm that is 85 feet from the bird. So where does the 85 go? Does the 85 go on the hypotenuse or on the bottom? Hypotenuse. Boys and girls, quit guessing. Read the problem. The worm is 85 feet from the bird. There's the bird. There's the worm. They're 85 feet apart. Now, if it said the worm is 85 feet from the base of the tree, then you would put it down here, right? Yeah. Okay, so look at the situation. Pick a function. Which one are you going to pick? Sine. You're going to say sine 52 equals x over 85. Is that correct? Opposite over hypotenuse. And x equals 85 sine 52. Got it? Okay, there's one more of these mini reviews. We're going to do that one, and then I promise I'll be done, but I want to do this last one because on Thursday, when I see you again, we're going to have a quiz. And I'm going to pick, I don't know yet how many, 3 or 4 or 5 problems from these mini reviews. So the one we did at the beginning of the period, the one we just finished, and there's some overlap, and now this new one. So here we go. I'm going to save number 1 for last because I'm not putting that one on the quiz, so we'll save that one for last, but the rest of these we should be able to just skim through. So number 2, find the, you already took a quiz over this, find the exact value. That means we're not typing it in, that means we're working it out like we did on our quiz. So, Olivia Hempelman, step 1, I'm going to draw a picture, right? Where am I going to draw it? In the first quadrant. Olivia knows that if that number's positive, it doesn't even matter what function I am. I'm in the first quadrant if it's positive. Patty, you better be paying attention or I'm going to go Hulk on you. Opposite over hypotenuse, 1/4. Which makes this side what? Root 15. That's good. Root 15. I want the tangent. Tangent would be 1 over root 15, which is root 15 over 15. Got it? What is the period? All right, this is what we talked about very first we got back from Christmas. We have 3 sine 2x and 2 cosine 1/3 x. Little caution, sometimes this is written like this. It's the same thing. Make sure you understand that. X over 3 is 1/3 x. So what's our strategy to find the period of this? We find the period of each piece. So the period here will be 2 pi over 2, which is pi, which means we repeat at pi, 2 pi, 3 pi, 4 pi, 5 pi, and so on. What's our period here? 2 pi over 1/3, which is 6 pi, which means we repeat at 6 pi, 12 pi, and so on. What's the first number that's going to show up in both lists? 6 pi. So the answer to the question is 6 pi. Number 4. Find a negative and just a negative angle coterminal with -10. How do you find coterminal angles? Add or subtract revolutions. So in degrees, that's 360. So we're going to add or subtract 360. If you add 360, you do not get a negative answer. This says give me a -1. So we're going to subtract 360, and the answer would be -370. If you draw a -370, it looks exactly like -10. stops at exactly the same spot, coterminal. Calculate the sine of, oh, this is a calculator. Doesn't say calculate, this is a calculator problem. All right, so I'm gonna go to my calculator, and I need the sine of 5 pi over 12. Now, what do I have to be careful of when I type this in? 5 pi over 12 is a radian measure. So make sure your calculator is set in radians. Or, what's your other option? Change it into degrees, and then type it in. It's so much easier if you're using a calculator. Just move your calculator to radians, and type sine 5 pi divided by 12. And what did you come up with as your answer? 0.9659? And number 6, in which quadrant is the secant negative, that less than 0 means negative, and the tangent positive, or also negative, I'm sorry, they're both negative. We want the tangent and the secant to both be negative. It's a little overwhelming to do them both together, so let's do one individually. Where would you have a negative secant? Now, that would be the same as a negative cosine, right? Okay, so where is the cosine negative? Which letter is cosine? X. Where is X negative? Here and here, right? Those are the two quadrants where you're going to have a negative secant. R over X. X is negative. Secant's negative. Cosine's negative. Now, where is the tangent going to be negative? Now remember, tangent's y over x. If that's going to be negative, tell me about y and x. One has to be positive and one has to be negative, right? Where does that happen? 2 and 4? So which quadrant has both? 2. We'll hang on to number 1. We'll do it tomorrow or Thursday. Somebody remind me we have to do that because that's a test question. We'll make sure we get it reviewed. But it won't be a quiz question. So, what happens on Thursday? We have a quiz. Quiz will be 3, 4, or 5 problems that are exactly like the ones on the 3 little reviews that we did today. Okay? Got it? All right. And then we will also do some more review